Okay, I want to take a few minutes and talk about power and how power relates to the work and energy topics that we've been doing so far in class. All right, quick review. Work. Now, work is done when we apply a force to an object and that object is displaced. We're doing work on the object. We're transferring energy to the object. Now, let's consider the situation that we have a lot of stuff to move. We are going to do the same amount of work whether we move all this stuff in little pieces or in one big trip. I'm going to show you a video clip. In it, I'm going to move some shelves. I'm going to move them from one desktop to a tabletop, and I'm going to do it twice.
I am going to do some work, and my lovely camera person, Ms. Thomas, is going to record how long it takes for me to do this work. All right? All right.
Of course you would do that.
Have to. And the last one. Done. Okay, I'm going to repeat the task, and Ms. Thomas is going to record how long it takes for me to do it this time. Did you get reset it? Excellent.
Start.
Go? Okay. Oh, I'm okay. Done.
In the first time, I did them one at a time. The second time, I did it in one big trip. The difference was how long it took to do that work.
Okay, so the first time I did it, it was just over 30 seconds. And the second time I did it, it was just over 5 seconds. I moved the same number of boards each time. The second time I did it in 5 seconds because I did them all at one time. The first time I did it 30 seconds, I did them one each.
Power is how fast work is being done, or how fast energy is being transferred. So the differences between the two trips was when I took all the shelves at one time, a lot less time, I used more power. Same amount of work, more power. Our equation for power is simply work divided by time. Now if we put in the expression for work and recognize that displacement divided by time is equal to velocity, another way to calculate power is by looking at the force and how fast the force is being applied. Not how far, that's work, but this is how fast the force is being applied. Now, in this case, work, of course, is in joules, times in seconds. Power is in joules per second, or the unit that we use is watts, capital W, named after James Watts, I believe. Basically, what this is telling us, that if we want to do work fast, more power is required. And vice versa is true. If we have a lot of power, we are going to do the work quickly. The more power, the faster we do the work. Now, when you say the word watt, I think the most common thing that pops to people's minds are light bulbs. We have 20 watt, 40 watt, 50 watt, 100 watt, whatever. And what that watt means is how much energy they consume each second. So this 100 watt bulb, this yellow bulb, is a 100 watt bulb. It uses 100 joules of energy every second. And all these bulbs might be different wattages, and they use different amounts of energy every second. And it's probably not surprising that a 100 watt bulb is typically brighter than a 60 watt bulb because it uses more energy. Now, one thing to note, these newer bulbs, these fluorescent type bulbs right here, are more energy efficient. They are rated usually like around 13, 14, 15 watts. They use a lot less energy per second. but the difference is they give off the same amount of light as a 100-watt bulb because they're more efficient. And that's really all we need to do with